was married and we were looking for a country place back in the 60s. It was a place to come and pretend to be hippies on the weekend. That's certified sustainably harvested local firewood. It's a tan oak mostly, which is considered a weed. It was just a country retreat for years, and then I was working in the computer industry in the Bay Area, and they built this fancy new headquarters building and sent out this 15-page employee handbook saying that we would no longer be able to turn off the fluorescent lights and bring in our own lighting and our own decoration. And I just said, no, I will not work under fluorescent lights. And I said, I'm out of here. Well, they said, okay, you're out of here. And so I moved up here, just cut off everything and started camping in a little cabin I built inside the barn. This was home for a few years. It was great fun. 8 by 12 plywood building, and that was the original place where I lived for years. Yeah, I built the whole thing. It was wonderful. That was actually one of the happiest times of my life. Actually, my main reason for building the house was to have something real to hang all my solar panels on. I didn't need that much space. As you'll see, once you get to see the house, a lot of it is the greenhouse or solar collector. I gradually built the house. Now, actually, I hired somebody to build the house, and they spent all of the money and built half of the house. And so I've been building the rest of it ever since. So what we've got here is the big glassed-in greenhouse or solarium area, which is collecting a lot of natural solar heat. And then 2 solar hot water panels on the right end and 8 solar electric panels across the top. And then the left end over there is a solar hot air collector, which right now is taking the heat from the top of the greenhouse, running it up the front of that slightly yellower path of metal, and can either close the top up there and push it into the house when you want more heat, or open the top and vent the excess heat out into the outside air. This is the outflow from the solar flue. And if you put your hand up here, you can feel the heat coming down. And then, of course, in the summer, when you don't want that heat, there's a lid up on top that the computer can open so that all the heat from the greenhouse and the excess heat that's right in here can just go right outdoors. Along the very left edge of the greenhouse in the back, there's a brown stripe. That's supposed to be glassed in so that the air that the vent sucks comes under the floor of the living room, down through the tunnel in the middle of this concrete block area, and then is sucked in through that grid. That's the intake for the whole solar flue tunnel. If it was operating, it would take hot air through that brown grid, down through the concrete blocks, under the living room floor, up the brown stripe along the far edge of the greenhouse, and then up along the roof and out through the ceiling. Right now I don't have the glass on the front, so it's not fully operational. And it has to be made out of really solid materials. The people who actually built the structure had used sheetrock and paint, and that was definitely not strong enough to handle the sun and the heat. So it's now all made of hardy board, the concrete and fiber board. My grandmother's house was built out of it 100 years ago. It's been around quite a while, and then it kind of disappeared, and then now it's come back as a fireproof material. It's wonderful stuff for building solar collectors out of.
But is that fairly inexpensive?
Yeah, solar hot air collection is very practical and very useful. It's just a little obtrusive. You know, it's like on the south side of your house, you need to have something that is a glassed-in box. And you can see a lot of this room is built of concrete block and poured concrete because we want the heat storage capacity of it. Yeah, as it turned out, for practicality, there should be less glass on the ceiling of the greenhouse because in the winter, the sun is at such a low angle, you could get almost as much heat without having all that glass. And in the summer, it's way too much. You have to actually cover it up. But it is pretty.
Okay. So you actually use this as a greenhouse as well?
Yeah, it's nice to have tomatoes in December. And these plants are now on their third year. They don't really pollinate themselves, so you have to come out here and tap them. I was the person who blocked the power lines because you know what they would have done is they would have brought a power line either all the way around the road right through all of my view, or they would have just jumped it right over the top of my house. And I just really didn't want that to happen to this beautiful area. And we tried to talk them into putting it underground, and they wouldn't even consider giving us a price to do that. They said you wouldn't even be able to do it. So some people have brought it down the back valley, but those of us on top really don't want it in the middle of our view. I've done very, very little as far as changing the landscape. Probably far too little.
The wood is just so nice.
Yeah, it's natural redwood that was actually grown here and milled here. It was down that hill when they first logged this area, probably 90 or 100 years ago. They didn't have good enough machinery to pull some of these big logs back up the hill if they rolled down too far. And so there were a lot of 4-foot trees down there that were beautiful old growth redwood that had just been abandoned. And so I hired one of the modern loggers with the biggest cat to go down there and get them. And brought in a mill and milled them into all that wood. And it's had absolutely nothing put on it, no kind of finish or anything. That's just what the sun and the weather does to it. And it's different. Everywhere you look and every part of it has gotten a different color and texture to it. It belongs here, it grew here, and it's the same kind of color and texture. These are the Sanyo 200-watt panels, and there's 8 of them, so 1,600 watts nominally.
Being completely off-grid, do you have to worry then?
Worry about what?
Right.
I don't have to worry that the power is going to go off accidentally, like the people down in the valley do. And I will look out sometimes and the whole valley is dark, and I say, oh, gee, their power's off. Mine never goes off. Right now, because I just put up a whole new set of panels, I have way more power than I'm used to. So it's unfortunate in a way that there isn't a grid that I could feed the power back into. I had noticed that all of my neighbors who have regular wood heating stoves tended to have something cooking on top of them, and I thought, well, why not just get a cook stove? Right around this area, it has a giant one-piece oval fire brick, which focuses the heat on the wood that you're trying to burn. And if that fire brick is hot, you can actually let the fire almost disappear and put new wood in there, and it will heat it up and get it going again. I'm very pleased with it. It's a cook stove. It has a full oven. The main advantage of fire brick is that it's very durable. Of course, the other advantage is its mass stabilizes the amount of heat that you have. It's really handy. For half of the year, you can cook in here and be cozy warm while you're doing it, and then The other half of the year, there's a gas stove outdoors. People from the south of the country come here and say, oh, you have a summer kitchen. They immediately recognize the concept of having another kitchen which is outdoors so that the heat from it does not get in your house in the summer when you don't want it. And of course the refrigerator is outside in the summer kitchen because most of the year it is cooler out here. There's probably a few very hot summer days when it would be cooler in the house, but in the summer, you have plenty of solar power, so it's not a problem. In the winter, when you have the minimum of solar power, you're not wasting it having your refrigerator fight your heating system. I grew up with a refrigerator that was on a back porch, but of course, people these days sacrifice everything to convenience.
So you do things a bit differently just because you're living off-grid. Do you see it as a sacrifice?
No, I look at it as an excuse to do things I wanted to do anyway.
Really? Why?
Well, for instance, I really don't like flickering lights. I not only see the flicker in fluorescent lights, I can see the flicker in incandescent lights. And it really bothers me. It's subtle, but after an hour or two, you're exhausted just from the light. So this is a perfect excuse to have a house where all the lights run on direct current. So the whole house is actually dual wired. There's 24 volts DC and 120 volts AC all around. And all the lights run on DC, but there's both kinds of outlets. This is something I developed. It's the double banana that is often used on lab equipment. And that's minus 12, 0, 0, and plus 12. So you can get either 12 or 24 volts, and those are all around the house, and then of course there's regular AC outlets. I have the inverter set to go to sleep by itself so that when AC power isn't absolutely necessary, it turns itself off. If you do believe that electromagnetic fields are a problem for humans, then it's just nicer to have the inverter shut itself down and not be making the electromagnetic field all around your house. This is the little house computer talking to me. Those are the various temperatures of the hot water sensors. It's 138 in the water tank and 147 coming out of the solar panels. Let's see. I don't know if you can hear that. That was the cover on top of the solar flue. And of course it's smart enough to know that it isn't supposed to be open right now because it's cold, so it just closed itself again.
Wow, it's a pretty smart house.
Yeah, it's amazing. There's over 10,000 lines of computer code that operate the water system and the electric system here. All custom written. You can access it from anything with a SSH terminal, so I can do it on my phone. So now it's going to go off shortly. Oh wait, no, that was the ozone going off. I need to turn it off. Off. It scans every 10 seconds to see if it needs to do something. So sometimes you need to wait a little while. That's what happens when you're a techie and you can change things. You do change things. This was originally old-fashioned analog controls for the first solar system, and it's gradually been converted to electronic control. So this is the heart of the system right here. It's a little 186 microcontroller. All of these wires go off to all of the different parts of the house that have sensors or actuators where things happen. And of course it was all done before the Zigbee radios became an option, so it's all hardwired. All this wiring here is low voltage DC wiring. This was all gathered from electronic surplus stores down in Silicon Valley and put together by me. Very handy to have a tech background when you're trying to provide your own energy. Down here in the corner we have a little tiny air compressor and an air tank. All of these doors all around the house that you see have air cylinders for locks. And they're all wired up to this key switch on the back porch. Here's the key. Put it in, turn it around. And you can probably hear that the little air compressor came on. When you leave the house, you don't have to go around and lock 12 different exterior doors. You turn one key and they all lock. And I'm totally amazed that that has not been developed for houses. I mean, nobody would think of buying a car that didn't have central locking. There are so many things to be learned when you do a project like this. If you look up at the right angle, you can see there's about 6 inches of empty space between the panels and the roof. That was a lesson I learned about the previous set, which were mounted much closer to the roof, and it trapped the heat underneath them, made the panel surface hotter, which makes them much less efficient. I very intentionally lifted these up off the roof and did not block the airflow behind them, so that the surface can stay cooler and they stay more in their efficient range. I think having a scientific education, it gets you to think about what could be changed and how could it be changed. This is the well right here. And at the bottom is a little tiny thing that's a electronically controlled variable speed pump, and then up in the closet upstairs is its electronic controller, and they talk to each other over electronic networking, and you can actually hook a computer to it and control exactly how fast the pump will run. So you can set it to use exactly the amount of power that your solar is providing. If you have the scientific background, you can understand what's possible and what can be done. But I think the bigger factor is just being willing to not do the conventional thing. Now here's an interesting thing. So a little heat down tube. It's just a piece of old sheet that's sewn into a circle. And it has a little computer fan at the top. And when you turn it on, it just keeps a continuous stream of the hot air that's collected up by the ceiling, takes it down here and blows it out near the floor. I have it right next to my work table so that if I have a fire going in the little stove over there and all the heat has collected up by the ceiling, this brings some down where my feet are. Very easy to make. Just a fabric tube and a little computer fan. I'm surprised that somebody doesn't manufacture these. Most people, they get a house, they want it to look like just everybody else's house. When you turn that off and just say, okay, I know what I want it to feel like, and I know how I want it to operate, then you have a whole different mindset. And then if you have the scientific background to understand what's possible and what can be done, you've got both things going for you. This is where the batteries live. I have not been forced to run the electric generator since I got these batteries. I can go through the entire winter on pure solar power. It's a literal ton of lead batteries. It is a problem. I mean, it's a very large amount of nasty metal and nasty chemicals, but if you treat them right and don't abuse them, they last quite a long time. The first set lasted 23 years. And of course there is still an engine generator over here. It's kind of, I think of it as a 1957 Cadillac. It's an old Onan, and it still runs.
Do you see yourself as exploring?
Oh, absolutely. One of the most recent explorations was the antifreeze for the hot water system. The solar panels were what you call drain down, where when it starts to freeze, the valve opens and all the water drains out of the panels onto the ground. That valve failed more times and finally broke the panels. So when I redid the system, I used antifreeze. It's in these pipes right here, and in the solar panels, and in the wood stove and heat exchanger that runs the hot water system. Well, now you've got the issue of you can't use ethylene glycol because it's poisonous, and if it gets in your water, you're in big trouble. But there's a new thing called Sustera. It's better specifications in every way than propylene glycol. It's the same price, and it's made out of totally renewable corn. And nobody seems to be using it. So I've tried it, and it seems to be absolutely fine. And I have to believe that the people who build hot water and solar systems commercially are just very conventional and are afraid to explore new things. But it seems to be working fine. It tests fine. Those go down under the house, down to the tank right behind the kitchen where you need the hot water, and right next to the bathroom where you need the hot water. What's in here is just dead water. It's not, you're not heating the water that you're using and storing it in a tank. You're heating an open tank, and inside there are two heat exchangers. One of them has the tubing that's coming down from the roof that's putting heat into this tank, and the other one has tubing from the domestic water system that flash heats your hot water as you need it. This is the heat that's coming back from the solar panels. 147, just like it said on the computer. What I use when there's no solar is this big old wood stove out here. These are the hot water coils that collect the heat. Because it feeds the same heat exchanger, you can heat the whole house from here. You can heat your domestic water from here. And then it has a sheet metal case around the outside and directs what would otherwise be wasted heat back into the bathroom through those brass grids here on the wall. And of course that heat goes directly up to the ceiling, which is why we want the heat down tube over there on the other side to suck it away from the ceiling and bring it back down to floor level. And it's amazing what a difference that little tiny tube makes. I worry sometimes that normal people would think that this is a very strange life I live here. You know, a lot of things that ordinary people absolutely would not tolerate, like there should be curtains across these closets. And someday there will be curtains across those closets. But the priority is getting new solar panels up and making the hot water system collect free hot water. Normal people want a house that their friends will all say, oh look, it's all finished and they did a beautiful job. So, you know, you have to be willing to give that up if you're going to explore what else could be done.